Okay, let us start. As per our syllabus, we need to discuss atomic physics. Atomic physics is the branch of physics which deals with the study of structure of atoms as well as the behavior of atoms under various conditions. Okay, so this branch where we discuss about the structure of atoms and the behavior of atoms under various conditions is what we call it as atomic physics. Okay, there are several models to explain the structure of the atom. So the first model that was actually proposed is what we call as Thomson's model. But we're not going to discuss about Thomson's model and all. I'm not going to mention anything about Thomson model. After Thomson model, there was another model put forward by a person called Rutherford. So therefore, the model is what we call it as Rutherford's nuclear atom model. I think you know. So this model is called as a nuclear atom model. It is because this fellow Ernst Rutherford introduced the concept of nucleus. Okay, so nucleus ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಬರೀ ಬಯಾಲಜಿನಲ್ಲಿ ಮಾತ್ರ ಇತ್ತು. ಸೆಲ್ ಒಳಗಡೆ ಬಯಾಲಜಿ ಓದ್ಬೇಕಾದ್ರೆ ಬಯಾಲಜಿಕಲ್ ಸೆಲ್ಸ್ ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಆ ಸೆಲ್ಸ್ ಒಳಗಡೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ಬರುತ್ತೆ. ಬಯಾಲಜಿನಲ್ಲಿ ಬರುವಂತ ಸೆಲ್ಸ್ ಒಳಗಡೆ ಮಾತ್ರ ನ್ಯೂಕ್ಲಿಯಸ್ ಇದೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ರು. ಆದ್ರೆ ಇವನು ರುದರ್ಫರ್ಡ್ ಏನ್ ಮಾಡ್ತಾನೆ, ಒಂದು ಆಟಮ್ ಒಳಗೂ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ಒಂದು ಪಾರ್ಟ್ ಇರುತ್ತೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸ್ತಾನೆ. ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾನೆ, ಪ್ರೂವ್ ಮಾಡ್ತಾನೆ, ಥಿಯರಿನ ಪ್ರಪೋಸ್ ಮಾಡ್ತಾನೆ. So that's why this model is what we call it as nuclear atom model. So according to him, each and every atom would be consisting of the central core part, and he called that central core part as nucleus. That's why this model is called as nuclear atom model. Okay, so plus please remember, so ನಾನು ಇಲ್ಲಿ ಬರ್ದಿರೋದನ್ನೇ ಓದ್ತಾ ಹೋಗಲ್ಲ, ಹಾಗೆ ಹೇಳ್ತಾ ಹೋಗ್ತೀನಿ ನೋಡ್ಕೊಳ್ಳಿ. ಓದ್ತಾ ಹೋಗಲ್ಲ, ಹಾಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೊಡ್ತಾ ಹೋಗ್ತೀನಿ. ನೀವು ಬೇಕಾದ್ರೆ ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಏನ್ ಬರುತ್ತೋ ಅದನ್ನ ಓದ್ಕೊಳ್ತಿರ್ಬೋದು. Okay, now he was an experimental physicist. He performed several experiments. Okay, out of those several experiments, one set of experiment is what we call it as scattering of alpha particles. Okay, so based on the scattering of alpha particles by thin metals, he proposed this particular model. Nuclear atom model was proposed on the basis of results of alpha particle scattering experiments. Okay, so based on those experimental results, he concluded in 1911 that each and every atom is consisting of a central part, core part, massive part, and a positively charged part. This core part, central part, massive part, or positively charged part, he called it as nucleus. Okay, why this is called a central part? Yakantandre idu atom in a central alli irutte. Why it is massive? Because most of the mass of the atom is concentrated in the nucleus. That's why it is massive, and it is positively charged. Okay, so atoms are consisting of positive charges and negative charges, and according to Rutherford, all the positive charges are concentrated on this nucleus. That's why that central part, core ಅಂದ್ರೆ ಮುಖ್ಯವಾದದ್ದು ಅಂತ ಹೇಳಿ. Okay, so then massive part, why it is massive? I repeat once again, it is according to him, most of the mass is concentrated in the nucleus, so that's why it is massive part. And as well as nucleus is positively charged, so according to him, all the positive charges are concentrated in the nucleus. And not only that one, so the nucleus is very small sized. Okay, it is so small, you can see here. So the dimension of a nucleus is of the order of 10 to the power of minus 15 meter. Okay, so 10 to the power of minus 15 meter is a very, very small number according to him. So the size of a nucleus is very, 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 very small. Okay, it is of the order of 10 to the power of minus 15 meter. In fact, this 10 to the power of minus 15 meter is what we call as 1 Fermi. Okay, so according to him, so size of a nucleus is order of the few Fermis, 1 Fermi, 2 Fermi, 3 Fermi. It all depends on the type of the nucleus. Okay, na? So that is what the thing. And so very positive charge idre atom stable ಆಗಿರಲ್ಲ. ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಇರಬೇಕು. ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಎಷ್ಟಿರುತ್ತೋ ಅಷ್ಟಕ್ಕೆ ಬ್ಯಾಲೆನ್ಸ್ ಆಗಬೇಕು. ಎರಡು ಬ್ಯಾಲೆನ್ಸ್ ಆದ್ರೆ ಆಟಮ್ ನ್ಯೂಟ್ರಲ್ ಇರುತ್ತೆ. ಆಟಮ್ ನ್ಯೂಟ್ರಲ್ ಆಗಿದ್ರೆ ಮಾತ್ರ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. So that's why he proposed, in order to balance the positive charge of the nucleus, he proposed that negatively charged electrons would be revolving around the nucleus in various circular orbits. Okay na? Follow ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Yes, sir.
Yes, sir. So it's very simple model. So he says each and every atom is consisting of positively charged nucleus, small sized nucleus, massive nucleus, core part nucleus. Okay, and the negatively charged electrons they would not be inside the nucleus, but instead they would be revolving. Electrons ಗಳಿಗೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಜಾಗ ಇರಲ್ಲ, ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಹೋಗಕ್ಕಾಗಲ್ಲ. ಅದ್ರ ಬದಲು ರುದರ್ಫರ್ಡ್ ಪ್ರಕಾರ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳು ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಸೊ ಸರ್ಕ್ಯುಲರ್ ಆರ್ಬಿಟ್ಸ್ ಅಲ್ಲಿ ರೊಟೇಟ್ ಆಗ್ತಿರುತ್ತವೆ, ನಾಟ್ ರೊಟೇಟ್, ಸೊ ಮೂವ್ ಆಗ್ತಿರುತ್ತವೆ, ರಿವಾಲ್ವ್ ಆಗ್ತಿರುತ್ತವೆ. ಅಂಡ್ ದ ನೆಸೆಸರಿ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್, ಅದು ಸರ್ಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇರಬೇಕು. ಆ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಅನ್ನೋದು ಸೊ ಪ್ರೊವೈಡೆಡ್ ಬೈ ದ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇಸ್ ಪ್ರೊವೈಡೆಡ್ ಬೈ obvious electrostatic force of attraction between the positively charged nucleus and the negatively charged electron. Positive charge nucleus ಮತ್ತೆ negatively charged electrons ಅಂತ ತಗೊಂಡ್ರೆ ಎರಡರ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ. That is what we call it as Coulombian force of attraction ಅಂತ ಕರಿತೀವಿ. It is this Coulombian force of attraction which actually provides the necessary centripetal force that is required for the circular motion of the electrons around the nucleus. Okay na? Okay, na ಕೇಳಿಸ್ಕೊತಿದ್ದೀರಾ?
Yes, sir.
Okay. Okay. Now the thing is, so although Rutherford model explained several things, but it could not explain two things majorly. Okay. So the first one is it could not explain the stability of atoms, and also it could not explain the atomic spectrum of hydrogen. This we have discussed in detail in the last semester itself. But anyhow, for the sake of continuity, I would like to give a small explanation for these things. Okay. As per Rutherford's model, atoms should not be stable. And the second one, so there is an experimental data regarding so the spectrum of hydrogen atom. Even our Rutherford model could not explain that experimental data of the hydrogen atom spectrum. Okay, atoms stable ಆಗಿರೋಕೆ ಸಾಧ್ಯ ಇಲ್ಲ Rutherford theory ಪ್ರಕಾರ. ಜೊತೆಗೆ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅಲ್ಲಿ ಯಾವ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ರಿಸಲ್ಟ್ ಇತ್ತು ಆ ರಿಸಲ್ಟ್ ಅನ್ನ ಕೂಡ ಯಾವುದನ್ನು ಕೂಡ Rutherford model ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಕ್ ಆಗಲೇ ಇಲ್ಲ. Okay, so please remember the thing is if the electrons are revolving around the nucleus in circular orbits, the electrons are negatively charged particles. If they are revolving in circular orbits, then they have centripetal acceleration. So if electrons have acceleration, then so they have to emit energy as per Maxwell's relations, Maxwell's electromagnetic equations. Okay, Maxwell's electromagnetic equation says that so whenever a charged particle is undergoing acceleration, then that the charged particle undergoing acceleration has to emit energy. Okay, and if our electron is accelerating, negatively charged particle is accelerating around the nucleus because it has centripetal acceleration, then it has to emit energy. So if it is emitting energy, then the total energy of the electron should become lesser and lesser and lesser. And ultimately, after the emission of all the energy, so the electron must actually fall into the nucleus. Okay, following this spiral path. And if the electron follows into the nucleus, so definitely, so atoms are not stable. Okay, na? ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲ ಎನರ್ಜಿ ಕಳ್ಕೊಂಡ್ಬಿಟ್ಟು ಸ್ಪೈರಲ್ ಪಾತ್ ಅಲ್ಲಿ ಸುತ್ತಿ 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 ಕೊನೆಗೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಬಿದ್ದು ಹೋಗ್ಬೇಕು. ಯಾಕೆಂದ್ರೆ ಎಲ್ಲ ಎನರ್ಜಿ ಕಳ್ಕೊಂಡ್ಮೇಲೆ ರೇಡಿಯೇಷನ್ ಎಮಿಟ್ ಮಾಡಿದ್ಮೇಲೆ ಅದು ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಬೀಳಲೇಬೇಕು. ಸ್ಪೈರಲ್ ಪಾತ್ ಅನ್ನ ಫಾಲೋ ಮಾಡ್ಕೊಂಡು ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಹೋಗಿ ಬೀಳಲೇಬೇಕು. ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಹೋಗಿ ಬಿದ್ದೋಯ್ತು ಅಂತಂದ್ರೆ ಆಟಮ್ಸ್ ಎಕ್ಸಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇರೋದಿಲ್ಲ. ಆಟಮ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಅಲ್ಲಿ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಅರ್ಥ ಏನು? ಆಟಮ್ಸ್ ಆರ್ ನೋ ಲಾಂಗರ್ ಸ್ಟೇಬಲ್. Okay, so therefore there is a problem of stability of atoms. So with respect to your new Rutherford model. Okay, and the second thing is if the electron is revolving in a spiral path and if it is emitting energy, then the radiation that the electron must emit must be a continuous one. It must be a continuous spectrum. Okay, so follow ಮಾಡ್ತಾ ಇದ್ರೆ ನಾನು ಹೇಳ್ತಾ ಇರೋದು.
Yes, sir.
An electron revolving around the nucleus loses energy because it is emitting energy. And while emitting energy, it is following a spiral path. So since it is following a spiral path, it loses energy continuously. So therefore, it emits energy continuously. And that emitted energy or emitted radiation must so form a continuous spectrum. So according to the Rutherford model, so an atom must emit a continuous spectrum. But whereas experimentally it has been established that atoms do not emit so continuous spectrum, they emit line spectrum only. So therefore there is another problem associated with the so Rutherford model. Okay, experiment ಮಾಡುತ್ತೆ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. ನೀವು ಯಾವ ಆಟಮ್ ಅಂತ ತಗೊಳ್ಳಿ, ಆಟಮ್ ನ ಎಕ್ಸೈಟ್ ಮಾಡಿಸಿದ್ರೆ ರೇಡಿಯೇಷನ್ ನ ಎಮಿಟ್ ಮಾಡುತ್ತೆ. ಆ ಎಮಿಟ್ ಆಗಿರೋ ರೇಡಿಯೇಷನ್ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲದೂ ಕೂಡ ಲೈನ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅಂತ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಬಟ್ ನಮ್ಮ ಸೊ Rutherford model ಪ್ರಕಾರ ಅದು ಸ್ಪೈರಲ್ ಪಾತ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಿರೋದ್ರಿಂದ so it has to follow so spiral path, so therefore it has to emit energy continuously. If the energy is emitted continuously, then it should form a continuous spectrum. ಸೊ ನಿಮ್ಮ ರುದರ್ಫರ್ಡ್ ಮಾಡೆಲ್ ಹೇಳುತ್ತೆ ಆಟಮ್ಸ್ ಕಂಟಿನ್ಯೂಸ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಯೂನಿಟ್ ಮಾಡಬೇಕು ಅಂತ. ಬಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ನೋಡಿದ್ರೆ ಆಟಮ್ಸ್ ಕಂಟಿನ್ಯೂಸ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಯೂನಿಟ್ ಮಾಡಲ್ಲ, ಲೈನ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಯೂನಿಟ್ ಮಾಡುತ್ತೆ. ಓಕೆನಾ? ಸೊ ದಟ್ಸ್ ವೈ ಬಿಕಾಸ್ ಆಫ್ ಆಲ್ ದೀಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಸೊ ದ ರುದರ್ಫರ್ಡ್ ಮಾಡೆಲ್ ವಾಸ್ ಸೊ ಸಮಥಿಂಗ್ ಲೈಕ್ ಯೂಸ್ಲೆಸ್, ಅಥವಾ ಅಷ್ಟೊಂದು ನೀಟಾಗಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೊಡಕ್ಕೆ ಆಗಲಿಲ್ಲ. ಓಕೆನಾ? Yes.
Yes, sir.
Okay. Now let us start with the Bohr's atom model. So just now I told, so your Rutherford's model could not explain many of the things. Actually, Rutherford's model, bari average fact matra anta ankobidi, it could not explain many of the things, but those two were the major things. Those two were the major things means, so the first one is like stability of atom, it could not explain, and it could not also explain so the spectrum of atoms, or spectrum of even the simplest one, so hydrogen atom spectrum adu explain madliಲ್ಲ ಅಂದ್ರೆ ಬೇರೆದೆಲ್ಲ explain ಮಾಡ್ತಾರೆ. ಹಾಗಾಗಿ ತುಂಬಾ ಕಡೆ ಫೇಲ್ ಆಯ್ತು. ಓಕೆ, ದಿಸ್ ಪರ್ಸನ್ Niels Bohr observed all these things, okay, and he extended actually Rutherford nuclear atom model in the year 1930. Okay, exactly after 2 years Rutherford put forward his model. So Niels Bohr in 1913 so proposed so certain modifications to Rutherford's model. Okay, and this modification after modification, so this model is what we call it as Bohr's atom model. Okay, so while doing these modifications, he simply made use of Planck's quantum theory. Okay, so ಇವನು ಏನ್ ಮಾಡ್ತಾನೆ, ಬೋರ್ಸ್ ಥಿಯರಿ ಸರಿ ರುದರ್ಫರ್ಡ್ ಮಾಡೆಲ್ ನ ಸ್ವಲ್ಪ ರಿಪೇರಿ ಮಾಡ್ತಾನೆ. ರಿಪೇರಿ ಮಾಡಿದ್ದು ಅವನು ಏನಿಲ್ಲ, ರಿಪೇರಿ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅವನು ಸೊ ಬರೀ ಪ್ಲಾಂಕ್ಸ್ ಕ್ವಾಂಟಮ್ ಥಿಯರಿನ ಇನ್ಕಾರ್ಪೊರೇಟ್ ಮಾಡ್ಕೊತಾನೆ, ಯೂಸ್ ಮಾಡ್ಕೊತಾನೆ, ಸೇರಿಸ್ಕೊತಾನೆ. ಅದನ್ನ ಸೇರಿಸ್ಕೊಂಡು ರುದರ್ಫರ್ಡ್ ಮಾಡೆಲ್ ನ ಸ್ವಲ್ಪ ರಿಪೇರಿ ಮಾಡ್ತಾನೆ. ಅದು ರಿಪೇರಿ ಮಾಡಾದ್ಮೇಲೆ ಅದು ಹೊಸ ಮಾಡೆಲ್ ಆಗುತ್ತೆ. ದ ನ್ಯೂ ಮಾಡೆಲ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ as Bohr's atom. Okay, so and he introduces so concept of stationary orbits, and also he introduced so the concept of quantization. ಈ ಕ್ವಾಂಟಮ್ ಥಿಯರಿನ ಸೊ ನ್ಯೂಕ್ಲಿಯರ್ ಆಟಮ್ ಮಾಡೆಲ್ ಒಳಗಡೆ ತಗೊಂಡ್ಬಂದು ಸೇರಿಸಿದ್ರಿಂದ ಒಂದು ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಒಂದು ಹೊಸ ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ, ಅದನ್ನ ಹೇಳ್ತಾನೆ. ಜೊತೆಗೆ ಆಂಗುಲರ್ ಮೊಮೆಂಟಮ್ ಕ್ವಾಂಟೈಸೇಷನ್ ಅಂತ ಬರುತ್ತೆ, ಅದು ಕೂಡ ಬರುತ್ತೆ. ಓಕೆನಾ? ಸೊ ದೀಸ್ ಆರ್ ದಿ ಪಾಸ್ಟುಲೇಟ್ಸ್. ಓಕೆ, ದ ವೆರಿ ಫಸ್ಟ್ ಪಾಸ್ಟುಲೇಟ್ is same as your Rutherford's model. Okay, even according to Bohr, an atom is consisting of a central positively charged nucleus, and the electrons, then negatively charged electrons revolve around the circuit in various circular orbits. Okay, and the necessary centripetal force is provided by the electrostatic force of attraction between the nucleus and the electron. Okay, so illೊಂದು ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದೀನಿ. ಸೊ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಏನಂತಂದ್ರೆ ಕೆಲವೊಂದು ಫಾರ್ಮುಲಾಗಳನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ, ಯಾಕಂದ್ರೆ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. Okay, if m is mass of the electron, v is the speed of the electron around the nucleus in a circular orbit, and r is the radius of the electron's orbit, the centripetal force is given by F is equal to minus m square by r. Do you agree? So the expression for the centripetal force of the electron around the nucleus is given by minus m square by r, where m is mass of the electron, v is velocity of the electron, r is the radius of the electron's orbit. Okay na, sari idya?
Yes, sir.
Okay, so then the electrostatic force of attraction between the nucleus, we are assuming nucleus has a charge plus Ze. Z can be anything. For example, if you go to the case of hydrogen atom, Z is equal to 1. In fact, we are going to discuss only for hydrogen atom later. But anyhow, let us write this expression in the general case. So therefore, if Z is the atomic number of the atom, then the nucleus actually carries a charge of plus Ze. And we are considering one single electron. Electron is revolving around, one single electron is revolving around the nucleus. So therefore, its charge is minus E. And according to Coulomb's law, the force is given by, the force of attraction is given by 1 by 4 pi epsilon Q1 Q2 divided by R square. Q1 is charge on the nucleus plus Ze. Q2 is charge on the electron minus E, divided by square of the distance R square, where R is nothing but square of the distance ಆಗುತ್ತೆ, ಅಥವಾ R is the distance, the radius of the circular orbit ಎರಡು ಕೂಡ ಆಗುತ್ತೆ. So therefore 1 by 4 pi epsilon naught minus Ze square by R square. Okay na, where Z is the atomic number of the element of the atom. ಅದಾಗಲೇ ಹೇಳಿದೆ. Now this equation 1 and equation 2 you can compare. So one side you can write the expression as minus m square by r. The same thing you can also write minus Ze square divided by 4 pi epsilon naught r square. So therefore you can actually compare equation 1 and equation 2. If you compare equation 1 and 2, you're going to get m square by r is equal to 1 by 4 pi epsilon naught Ze square by r square. ಎರಡು ಕಡೆ minus sign ಬಂದಿದೆ, minus sign ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತೀವಿ. ಹೌದಾ? ಫಾಲೋ ಮಾಡಿದ್ರಾ?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Then, okay, this is what the first postulate. Please remember, this is the first postulate. First postulate of Bohr's theory is the same old as we discussed in the case of Rutherford's model. Rutherford's model ಅಲ್ಲಿ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವು ಅದೇನೇ ಕೂಡ ಇಲ್ಲೂ ಇದುವರೆಗೂ ಡಿಸ್ಕಸ್ ಮಾಡಿರೋದು. ಇನ್ನೂ ಹೊಸದಾಗಿ ಏನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿಲ್ಲ. ಹೊಸದಾಗಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಆಗೋದು ಸೆಕೆಂಡ್ ಪಾಸ್ಟುಲೇಟ್ ಮತ್ತು ಥರ್ಡ್ ಪಾಸ್ಟುಲೇಟ್ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಸೇಮ್ ಒಟ್ಟಿಂಗ್ ನಾವೇನು ಮಾಡಲಿಲ್ಲ, ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರ್ಕೊಂಡು ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರ್ಕೊಂಡ್ವಿ ಅಷ್ಟೇ. m²/r = 1/4πε0 z²/r² ಅಂತ ಹಾಕೊಂಡಿದೀವಿ. ಸೊ ದಿಸ್ ಈಸ್ ಯಾಕೆ ಅಂತಂದ್ರೆ ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ರೇಡಿಯಸ್, ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ರೇಡಿಯಸ್. ಅದಕ್ಕೋಸ್ಕರ ಸೈಮಲ್ಟೇನಿಯಸ್ ಆಗಿ ಪಾಸ್ಟುಲೇಟ್ ಹೇಳ್ತಾ ಇದೀವಿ, ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕೂಡ ಬರ್ಕೊತಾ ಇದೀವಿ. ಓಕೆ, now let us move on to the second postulate. So according to second postulate, Rutherford says an electron can revolve around the nucleus in any possible orbit. ಎಲೆಕ್ಟ್ರಾನ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಸುತ್ತಾ ಇದ್ರೆ ಅದಕ್ಕೆ ತನಗೆ ಇಷ್ಟ ಬಂದಿರೋ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ರೌಂಡ್ ಹೊಡಿಬಹುದು ಅಂತ Rutherford ಹೇಳ್ತಾರೆ. But here Bohr says an electron cannot revolve in all possible orbits around the nucleus. It can only revolve in certain set of orbits. Those selected set of orbits are called stationary orbits. So therefore he introduced the concept of stationary orbits. I repeat, an electron cannot revolve in all possible orbits around the nucleus, unlike the case of Rutherford's theory, Rutherford's model. An electron can revolve around the nucleus only in some selected set of orbits. These selected set of orbits are called stationary orbits. Why they are called stationary orbits? It is because as long as an electron is revolving in one such stationary orbit, it does not emit energy. If it is not emitting energy, so therefore it does not lose energy. If it is not losing energy, then obviously, so an electron cannot fall into the nucleus. If electron cannot fall into the nucleus, obviously atoms would be stable. Okay na, gottagtidiya? So therefore, by introducing stationary orbits, he told atoms are stable. Just by introducing stationary orbits, so he says that atoms are stable. How atoms are stable? Because if an electron is revolving in one such stationary orbit, it does not lose energy. If it is not losing energy, its total energy remains constant. If its total energy remains constant, then it will keep on revolving in the same orbit without falling into the nucleus. That's why if it is not falling into the nucleus, therefore atoms are stable. Okay na? So this is what the speciality of stationary orbits. And there must be certain condition for stationary orbits. Okay, I told not all orbits are possible, only some orbits are possible. How do we select some orbits? Kelvond orbits gal matra hege select madkododu? So that is actually because of quantization of the angular momentum. He says an electron can revolve around the nucleus in only those orbits in which the angular momentum of the electron is an integral multiple of h/2 pi. Okay, I think you know h is what we call it as Planck's constant. Yava orbit alli electron angular momentum, let me say electron angular momentum is written as capital L, and it is given by the product of mass, velocity, radius mvr. And yava orbit alli angular momentum nh/2 pi agutto, where n is equal to 1 2 3 etc. So yava orbits alli ee condition satisfy agutto ಆ ಆರ್ಬಿಟ್ಸ್ ಗಳು ಮಾತ್ರ ಅಲೌಡ್, ಆ ಆರ್ಬಿಟ್ಸ್ ಗಳು ಮಾತ್ರ ಏನಾಗುತ್ತೆ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ಸ್ ಆಗುತ್ತೆ. Okay, for example, if I substitute n is equal to 1, angular momentum becomes 1h/2 pi. That is called first allowed orbit ಅಥವಾ first stationary orbit. If I substitute n is equal to 2, L becomes equal to n is equal to 2 ಆಗರಿಂದ 2h/2 pi ಆಗುತ್ತೆ. That is second allowed orbit or second stationary orbit. If I substitute n is equal to 3, so then the angular momentum becomes 3h/2 pi. ಯಾವ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ angular momentum 3h/2 pi ಆಗುತ್ತೋ that is third allowed orbit or third stationary orbit and so on. Okay na? So therefore this is what we call it as quantization of angular momentum. So equation 4, which says that angular momentum L is equal to mr is equal to nh/2 pi is what we call it as quantization of the angular momentum. ಯಾವ ಜಾಗದಲ್ಲಿ angular momentum quantize ಆಗುತ್ತೋ ಅಲ್ಲಿ ಆರ್ಬಿಟ್ಸ್ ಗಳು ಮಾತ್ರ ಇರಕ್ಕೆ ಸಾಧ್ಯ. ಆ ಆರ್ಬಿಟ್ಸ್ ಗಳನ್ನ ನಾವು ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Okay na? That is what the thing which was actually proposed by Niels Bohr. Okay, and n can only take integral set of values. ಅದು ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಮತ್ತೆ ಇನ್ನೊಂದ್ಸಲ ರಿಪೀಟ್ ಮಾಡ್ತೀನಿ. n can take only 1 or 2 or 3 etc. It cannot take a value of let us say 1.75. ನಿಮ್ಗೆ ಇಷ್ಟ ಬಂದಿರೋ ನಂಬರ್ ನ ಹಾಕೋಕ್ಕಾಗಲ್ಲ. n ಗೆ ನೀವು ಕೊಟ್ರೆ ಇಂಟೆಗ್ರಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಮಾತ್ರ ಕೊಡ್ಬೇಕು. 1 2 3 4 5 6 ಅಂತ ಮಾತ್ರ ಕೊಡ್ಬೇಕು, ಅದು ಬಿಟ್ಟು ಬೇರೆ ಏನು ಕೊಡಬಾರದು. ಓಕೆನಾ? So therefore we say that angular momentum can take only some restricted set of values. ಯಾವ ಜಾಗದಲ್ಲಿ angular momentum restricted set of values ತಗೊಳುತ್ತೋ ಆ ಜಾಗದಲ್ಲಿ ಮಾತ್ರ ಆರ್ಬಿಟ್ಸ್ ಇರುತ್ತೆ. ಆ ಆರ್ಬಿಟ್ಸ್ ಗಳನ್ನ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಆ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದ್ರೆ ಅದು ಎನರ್ಜಿ ಕಳ್ಕೊಳ್ಳಲ್ಲ. ಅದು ಎನರ್ಜಿ ಕಳ್ಕೊಳ್ಳಲ್ಲ ಅಂತಂದ್ರೆ ಎನರ್ಜಿ ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. ಎನರ್ಜಿ ಫಿಕ್ಸ್ ಆಗಿದ್ದಾಗ ಅದು ಸೊ ಆರ್ಬಿಟಲ್ ರೌಂಡ್ ಹೊಡಿತಿರುತ್ತೆ ಹೊರತು ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಹೋಗಿ ಬೀಳೋದಿಲ್ಲ, ಹಾಗಾಗಿ ಆಟಮ್ಸ್ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. Okay, this is what the second postulate, and I think clearly I can say that this n is what we call as so principal quantum number.